Hello everyone, let's start with this lecture. We study signals versus linear systems, discrete systems. Time domain analysis module. Hello, we are starting part 5 today. The learning of the time domain analysis of discrete system. Today, we are going to talk about part 4. Double zero response of discrete LTI systems. Let's start with the zero input response. The basic concept of zero state response. Zero input response for the difference equation. The input is zero and the difference equation is homogeneous, so the zero input response solution is in the form of homogeneous solution. The undetermined coefficient C is determined by the initial state of the system. The zero state response is equivalent to zero in the initial state. A response produced simply by an external excitation. The solution method for inhomogeneous difference equations. There are two main types of solutions. First, classical method. That is to say, we introduced the method of homogeneous solution plus special solution. The second method is the convolution sum, which I will describe later. So, let's do an example where we solve for the zero input response. Given the difference equation of LTI system, input excitation y of 0, y of 1, the initial value of the given response. Find the zero input response of the system. According to the concept of zero input response, so that means that the plus excitation f of k is equal to 0. So the difference equation becomes a homogeneous difference equation. According to this form, we get its characteristic equation. The form of the zero input response solution. It depends on the form of a single characteristic root. Let's give it an expression. So the form of edge C1 and C1 here is determined by the initial conditions. And we are given y of 0 and y of 1 is the initial value of the full response. Therefore, we need to analyze the initial value accordingly. So, how do we get the initial value of y of 0 from the full response y of 1? Let's solve for the initial state y of minus 1 and y of minus 2. We can use the iterative form of the difference equation to solve iteratively. Iterative expression. Then you can see that this is an expression like this. So let's figure out what value of y of minus 1 and y of minus 2. So, what does y of minus 1 and y of minus 2 have to do with this undetermined condition for the zero input solution? Y of minus 1 and y of minus 2 have two types. One is the zero state response part, and then there's a zero input response, because before the additional incentive is applied, the zero state response part is 0. So y of minus 1, y of minus 2 is the same thing as yz of minus 1 and yz of minus 2. So we get a relationship that looks like this. We can take the values of y of minus 1 and y of minus 2, take the initial value of the equation as the zero input. So you can see that we get two expressions that look like this. So we can determine the value of C1 and C2. So let's take that back to our analytic expression. The zero input response results in the solution. That's the general way to solve the zero input responses. So what happens when we are done with the zero input response? Now let's look at the solution to the zero state response. The zero state response when we solve, it is equivalent to the initial condition being zero, a response simply caused by the external stimulus. What about the form of the difference equation? It is a form of non-homogeneous difference equation. Its solution method is based on the classical method of difference equation. The way to solve the homogeneous solution plus particular solution, so we can follow the classical solution that we saw in the last video to discuss how to solve the zero state response. Thank you. That's all for today. Thanks.